Okay, good afternoon. So in the last lecture, we have started the syllabus of our subject, advanced subject, that is the advanced concrete technology. So we have covered the some of the outcomes of this particular course. So 4 outcomes we have seen. Then we have seen the syllabus of section 1. So there are 4 units in the section 1 that syllabus we have covered in the last lecture. So we will see the syllabus of second section, and in the second section, whatever the units are there, that we will see first, and then we will continue with the unit 1. Okay, so here the unit number 5 in the section second, the unit number 5 is the special processes and technology for a particular types of structure. So there are various types of the structures in the field of civil engineering, and for that structures we have to construct the structures by using the concrete as a material. So for so while constructing the these particular structures, so mass concreting is there, and while constructing the structure, that mass concreting is the ingredients of concretes are the cements and aggregates like this. So mass concrete. So where mass concrete we are using, so some of the retaining walls are there, chimney structures are there. So their mass concrete we are using. So it means in the huge amount of concrete is required to construct that particular structure. Then spread concrete, then ferro cement concrete, pumped concrete, roller compacted concrete. So such various major types of structures we are using the concrete as a material. So sometimes we have to pump the concrete. It means at a higher grade, a higher level, or at higher height, we have to place the concrete from the ground. At that time, we have to use pump for the placing the concrete at a higher height. So at that time, we have to pump the concrete. So such how to pump concrete, what are the their what we can say capacity of the pump. Then roller compacted concrete. So sometimes we are compacting the concrete. So we have seen the various needle vibrators we are using for the compaction of concrete in column, concrete in beam, concrete in slab. So the compactors we are using, and for that compactor, so roller compactor is there. So if mass concreting is there, so roller compactor we are using. So and sustainability of the concrete industry. So the concrete industry, it means we are taking the concretes from the some RMC plants, like. So these are the concrete industry. So special process and technologies are required for mass concrete, then roller wave compactions, then pumping of the concrete, ferro cement concrete. So that we will learn in this particular unit number 5. So then unit number 6. So unit number 6 is the ready mix concrete, RMC. Ready, R, mixed M, and C, ready mixed concrete. It means what? Ready mixed concrete is nothing but, so ready mixed concrete is nothing but actually we are taking the concrete from the RMC plant. So nearby the site area, the plant is there. So in the plant, so we are mixing the concrete in the plant, and that transferred or transported by the concrete mixers, which are which consist of drum. That drum is rotating from the site, from the RMC plant to the up to the site. So we are that RMC concrete nowadays we are using. So it means on site, not mixing the concrete. So we are calling the concrete from the RMC plant. So types of plants that we will see in this particular unit. Then concrete specification, then process adapted for central RMC plant. So how plant is working. So there are computerized automatic plant is there. So it means just only we have to give the inputs what inputs, how much kg cement required for 1 meter cube, that we have to give 8 bags. Then we have to give the a requirement of sand. If 700 kg sand is required for 1 meter cube, then aggregate, so 1200 kg aggregates are required for 1 meter cube. So the automatically that aggregate 1200 kg aggregate, 700 kg sand, then 8 bags of cement automatically lifted from the units. So the automatic RMC plant is there, and also water requirement is automatic. It means nowadays the only we have to give the input to the computer, and that computer by whatever input given to the computer system through online automatic system, we can take the sand, cement, aggregate, and we will mix in the mixer in the RMC plant, ready mix. So, and that is the nowadays every taluka level city also nowadays RMC plants are there. So distribution and transports, how to distribute and transport this concrete from the RMC plant. So as I told, concrete mixer, have you seen the concrete mixers? What is the capacity of concrete mixer? Anyone can tell me? Capacity of one concrete mixer? Whatever concrete came from the RMC plant, so the whatever capacity of, what is the capacity of that mixer, concrete mixer? Anyone can tell me? No one is ready to tell. So the capacity is of concrete mixer is a 6 meter cube. So you have seen the mixer, the rotating drum is there. So from the RMC plant to the site, the rotating mixer is a continuously rotating. Why? Because do not set this concrete in the particular mixer. Are you getting? So that's why. So this is the distribution trans that we will learn in detail. That code recommendations, some of the codes are there. On the basis of that code, we can mix the concrete in the RMC plant. Then quality control. Quality control we have to check. So it means how proper quality we have to maintain when concrete we are making in the RMC plant. So this is related to the unit number 7, that is the RMC plant. Then unit number 7, the unit number 7 is mixed design. So very important point is the mixed design. While you are making the concrete or preparing the concrete, so mixed design is very important. What is mixed design? So generally mixed design is depends on the grade of concrete, which grade of concrete you are using. So which grade? So where there are various types of grade, M10, M15, M20, M25, M30, M35, 40, 60, 80, 90, 100. So there are so many grades concretes we are using. So the grades, it means what? M35, it means what? M is the mix. What mix? Cement, sand, aggregate, that we are mixing. Basic ingredients are cement, sand, aggregate. After that, we are adding some admixtures for the early getting the strength. But the basic ingredients are cement, sand, aggregate, or sometimes we are replacing cement to this other material. We are replacing aggregate to the other material. So that is the additions, but basic ingredients are cement, sand, and aggregates. So how much mixed design means how much quantity of cement is required for M35 grade, how much quantity of sand required for M35 grade, how much quantity of aggregate required for M35 grade. So that we have to calculate depends upon the sum of the parameters of that material. So how much water absorption of the aggregate, how much of water absorption of sand. So depends upon that particular particles or properties, or some of the specific gravity we have to check for the sand aggregate. So in this particular unit we will take the sample for various grades of mixed design. It means we will design M30 grade concrete or M35 grade concrete, and how much proportion for M35 grade concrete, that will be calculated in this particular unit. So then a review of methods and philosophies. So IS code is there for this particular design. Then mixed design for special purposes. So high grade concrete we have to design high grade concrete. So high grade concrete means, so generally up to the M25 grade, generally up to the M25 grade. So general proportion we can use 1:2, 1:2 is the proportion for M25 grade. For M10 grade, 1:3, 3:6. For M15 grade 1:2, 4. For M20 grade, 1:1.5:3. So these are the standard proportion for these particular grades. But more than 25 grades, if we go for the mixed design, then we have to mix design M30, M35, 40, 50, 60, likewise. So high grade concrete we have to use, then we have to do the mixed design by using this IS code. So IS, there are two methods are there, IS method, and one more method is there that we will see in the detail at the time of this chapter. And variability of results. So how to do the mixed design, that we will learn in this particular unit. Then next unit number 8 is the quality concept. So definition, principle and standards, quality control in the concrete construction, tools for the quality management. We are preparing the concrete, but whether the quality of concrete is good, how we can decide? Quality of concrete is good. So what parameters we have to think about the quality of concrete? So that parameters we will learn in this particular unit. That is the definition, then principle and some standards, then quality control in the concrete construction, and tools for the quality management. Then unit number 9. So unit number 9 is a repair and rehabilitation. Unit number 9 is a repair and rehabilitation. So the visual inspection, so repair and rehabilitation. So generally the structures are constructed by concrete. Okay, nowadays all the structures were constructed by concrete and others are the steel structure, but most of the structures we are constructing by using the concrete. So repair and rehabilitation. So by after some days or after some years, there may be deterioration of structure. So how to repair and rehabilitate that structure? So visual inspection of the concrete. What damages, what type of damages occurs to the concrete? There may be the cracks are there, there may be the water saturation area is there, or there may be a exposure of steel is there from steel called RCC slab. So likewise, visual inspection we have to see in this particular unit. After this visual inspection, distress in concrete. Some have you seen? There are cracks you have seen the to the structures cracks. Then for repair and rehabilitation, we have to take the test on the concrete, that are the non-destructive tests are there. So how to know the structures, the strength of the concrete is good, or whether the structure is deteriorate or not deteriorate, that we can test by using the non-destructive testing. Then cracks repairs techniques. Sometimes we can see the cracks to the beams, cracks to the columns, cracks to the slabs. Why these cracks happen? Because some due to the distress, cracks will be happen, or due to the settlement, one side settlement of column, at the because of this some cracks will be seen. So that cracks repair, how we can repair that cracks also, and damages we can durability of that structure we can improve. Then damage assessment procedure. we have to see. Then deterioration, causes and prevention. So as I told, deterioration means what, some in terms of G's or wear and tear or some damages, that is the deterioration. Because structure is having after 20-25 years or 30 years, due to the environmental impact, the structure may be deteriorate. So there may be cracks or weakening of the concrete, corrosion of steel. So that is the deterioration. So that how it causes, or how we can prevent, that we can learn in this particular point. So strengthening techniques. If the structure deteriorate, if the cracks observed, if damages observed, whether we can strengthen the structures. Yes, some of the techniques are there, that techniques we can use for the strengthening of the structures. That strengthening techniques are there. So these are the some 9 units are there. That 9 units we have to learn in this particular subjects. So our subject name is the advanced concrete technology. It means whatever you have learned in the concrete technology, that is related to how to prepare concrete, what is workability, what is that you have learned. But in the advanced concrete technology, some advanced part you have to learn. So that is the RMC plant, repair and maintenance, then mixed design, or special higher grade concrete. So some of the parts, this is the advanced part of the concrete that we have to learn in these particular subjects. So these are the 9 units we have to see. Then some of the practicals we have to perform in the laboratory. That practicals are the test on the fresh concrete workability test. So workability test of the fresh concrete we have to conduct. Then hardened concrete. So strength test comparison, strength test compression flexure. It means any type of concrete we have prepared, so that how much strength of that concrete, how much flexural strength of that concrete we have to learn. Then effect of additives in concrete. Effect of additives. So additives means what? So ingredients of concretes are cement, sand, aggregate. Are you getting? So nowadays we are replacing sand by the crushed sand. Are you getting? So these are the 3 main elements of concrete, or main ingredients of concrete. But in this we are some additions we are doing. So we are replacing 10 to 25% by fly ash to the cement. Sometimes we are replacing sand to the crushed sand. Sometimes we are adding the admixtures to get early strength or to get higher strength. So such additives we are adding, and for that we have to test the whether the strength of the concrete is maintaining or getting higher. Then effect on workability of strength. These 2 parameters we have to find, strength and workability of concrete, by adding the additives. Then effect of admixtures in the concrete. Here additives means fly ash we are adding, silica flame we are adding, some fibers we are adding in the concrete. That is the additives. And admixtures, so some of the admixtures are available in market. For what purpose? To get the early strength, to maintain the water cement ratio. So for that purpose we are editing these admixtures. So effect of workability and strength also we have to learn for these admixtures. Then mixed design of for the higher proportion. So manually and experimentally. So in the class we will do the mixed design manually, by numerically, and that with the help of this mixed design we are conducting the experiment in the laboratory. And then next experiment is a non-destructive test of the concrete. So how to perform the NDT for this particular test of the to know the strength of the concrete. So there are rebound hammer test and ultrasonic pulse velocity test we will perform in the existing building, our building, college building, and I will show you how to perform this non-destructive test and how to get the result, or how to know the quality of the concrete and strength of the concrete. So this is the related to laboratory part. Then some textbooks are there. The textbooks are the concrete technology theory and practice by the MS Sethi. Then yes, Chand, the publication is author for this particular book. So you have seen this book, I think, in the concrete technology in secondary engineering. So concrete technology by MS Sethi. Then concrete mix design by N. Krishna Raju is the another textbook is available in our library also. So then reference books are available for these particular subjects is are the high performance concrete by PC Atkin, then concrete technology by AR Santa Kumar, then concrete technology by Neville, then advanced concrete technology and constituent material for the John Newman, and the concrete is the PK Mehta. So these are the 5 reference books, and 2 textbooks are also available for this our subject. So we will get the literature from this particular book. So in this way, we have covered the syllabus and some of the experimental work and textbooks required for this particular to cover this particular syllabus. So this is up to the syllabus of the subject. So now we will start the unit number 1 and we will see what contents in the unit number 1. So this is the our unit number 1. So the name of subject is our advanced concrete technology. Unit number 1 is the ingredients of concrete. So the ingredients means this is actually brush up. Unit number 1 is a brush up of your concrete technology. So unit number 1 part you have learned in the concrete technology. All the part you have learned in the concrete technology. But to learn this advanced technology, some of the brush up part we will see in this unit number 1, and then unit number 2 onwards we will see the advanced part of this concrete technology. Okay, so the ingredients of concrete, this is the unit number 1. So we will see the ingredients of concrete. So first ingredient of concrete is a cement. So generally the cement is one of the most important part of the concrete. So that we will learn in the what we have to learn these particulars under the cement. So cement. So the hot and dry manufacturing process of cement that we have to see significant of the physical properties. Then these are the some physical properties we have to see. And then chemical compound properties we have to see, and then types of cement we will see in this particular part related to cement. Okay, so what is cement? Okay, so cement. So what is cement? Cement is a binding material. We know cement is a binding material, which is the mixture of calcareous, siliceous, argillaceous, and other substances. So actually cement is a binding material, and which includes this is the mixture of this all materials. So again, cement is a hydraulic binder and defined as a finely ground inorganic material, which when mixed with the water forms a paste which set and hardened by the means of hydration reactions. What is cement? Again, cement is a binding material, and that will be the mixed with the water, and we can perform the paste. That will be the set by the harden, and the hydration reactions will take place. and the cement paste or concrete will be the prepared. So process the reaction and process which after the hardening retain the strength and stability. So after the setting of the cement, it means hydration process. After the hydration process, we'll get the strength and stability of that uh, uh, cement if we add the water. Then manufacturing process of cement, how we can manufacture the cements. So generally, the India is second largest country in the world as per the 2019 record. India is the second largest producer in the world as per the 2019 record, producing the 502 million tons of cement per year. 502 million ton of the cement per year. So this is the second largest country in the world, in India. The cement manufacturing industries share the major part in the Indian economy. So if we talk about the Indian economy, so the cement manufacturing industries are the making the major role for the Indian economy. The raw materials required for the manufacturing of Portland cements are calcareous material such as limestone, chalk, aggregaceous material such as shale or clay. So this material, limestone or chalk and shale or clay. So this material we are using for the manufacturing of cement. So cement factories are established where these raw materials are available in the plenty. Cement factories have come up in the many regions in India, eliminating the inconvenience of long distance transportation of raw finished material. So the overall India, the cement factories are established. So where the materials, this limestone or clay or chalk material is available in the India. So then, so if we talk about the manufacturing process of the cement, so then the process of manufacturing of cement consists of grinding the raw material, then mixing them initially in the certain proportion depending upon their purity and compositions. Again, burning them into the kiln. So whatever raw materials are there, what are the raw materials are there? Limestone is a raw material, chalk is a raw material, clay is a raw material to prepare or to make the cement. And that material we are burning into the kiln at a temperature of 13000 to 1500 degrees Celsius. At with this temperature, the materials are clinked, or materials giving the shape into this clinker, and the clinker is cooled and ground to fine powder addition with the about 3 to 5% of gypsum. So we are adding the 3 to 5% of gypsum after the grinding of the materials, that raw materials. So that product formed by using this procedure is a Portland cement. The product formed by using this procedure is a Portland cement. So how we can make the Portland cement? So Portland cement we can make by using this raw material. That raw material we are grinding into the clinker, and after the clinker, that grinding material cooled, and after the cooling of grinding material we are adding the gypsum, that is the 3 to 5%. So this question will be asked for competitive examination or MCQ examination. How much percentage of gypsum we are adding in the cement? So 3 to 5%. So again, there are two processes, wet process and dry process of the manufacturing of cement. Depends upon their mixing and grinding of raw material is done when dry condition. And the mixed with about 10 to 14% of water for further burn in the clinking temperature. So the wet and dry process that we will see, what is wet process and what is dry process of manufacturing of cement. So you can see here wet process. This is the wet process. So in the wet process, in one side, limestone is a raw material we are adding. In other side, clay is a raw material we are adding. That clay is a washing. Then it comes into the storage basin. Then this limestone comes under the crusher. Then comes under the storage basin. So from these two storage basin, the wet grinding mill to make slurry. So clay and this limestone will come together. Then blending of slurry to correct composition, and then storage of corrected slurry. So powdered coal, oil and gas is then mixed, and corrected slurry comes into the rotary kiln. From the rotary kiln, again slurry is converted into the clinker, and after the clinker, it will be the clinker is ground in the ball mill. After the clinker, here gypsum is added 2 to 3% in the clinker, and then cement silos are there. So we are storing the cement in the cement silos. After the cement comes out from the clinker, then we are storing this cement in the cement silo, and after that we are packing the cement in the bags. So the generally the 50 kg bag we are making of cement, and we are dispatching for the making the concrete on the overall requirements sites. So this is the wet process of the manufacturing of the cements. Then you can learn, you can see here, this is the flow chart of the manufacturing of cement. Whatever we have seen in the in word we have seen this, and this is the by flow chart. Through chart, same process, manufacturing process we are using. Then significance of the physical properties. So what are the physical properties of cement? So there are 4 to 5 physical properties of cement: fineness of cement, then initial and final setting time of cement, then specific gravity of cement, then soundness of cement, hydration, heat of hydration. So such physical properties of cements that we have to learn, or that we have to know while we are before the using of this particular cement. Okay, so what is fineness of cement? So fineness of cement, this is the first physical property. So these properties you have learned in the second year civil engineering in the concrete technology. So just we have to brush up this unit number 1 related to for all the parameters or all these physical properties or ingredients of concrete. So generally the size of particle of the cement is fine. Have you seen? The cement is just if we take the cement on the hand, the very fine particle. The required fineness of good cement is achieved through the grinding the clinker in the last step of the cement production. So the cement particles should be very fine. Cement particles should be very fine, and at the stage of grinding in the clinker, that will make the fine. Then now what is fineness? So fineness or a particle size of Portland cements affects the rate of hydration. So the rate of hydration depends on the fineness. The rate of the strength here. The smaller size particles, if the smaller size particles are there, the greater of the surface area to the volume ratio, and the more area available for water cement ratio interaction per unit volume, then the effect of greater fineness on the strength are generally seen during the first 7 days. So generally, fineness of the cement is a very plays very important role uh, about the water cement ratio. So water cement ratio, it means when we are adding the water into the cement, so there is a volumetric changes there. So for that, the fineness is very important. Then when the cement particles are closer, hydration start to the surface of the particle. So the coarser particles may not completely harden. Here said, if the coarser particles are there, finer particles and coarser particles. So coarser particles are there, they may not be completed proper hydration process. म्हणजे हायड्रेशन हे प्रॉपर होत नाही जर पार्टिकल कोर्सर असतील तर. जर फायनर पार्टिकल असतील तर हायड्रेशन प्रोसेस व्यवस्थित होते. सो दिस कॉजेस द लो स्ट्रेंथ अँड लो ड्युरेबिलिटी. इफ द कोर्सर पार्टिकल्स आर देअर, सो इट कॉज द low strength and low durability. So if you see this picture, the cement is a very fine particles are there. Then next is the consistency of cement. Next physical property is the consistency of cement. So what is consistency of cement? So consistency of cement is nothing but the ability of cement to flow it consistency. So it means and that consistency we can measure by the VCAT apparatus that you have done the practical on this particular also. So the VCAT apparatus we are using. The VCAT apparatus cement paste of the normal consistency is taken into the VCAT apparatus, and the plunger of the apparatus is brought down to the touch top of the surface of the cement, and the plunger will penetrate in the cement paste up to the certain depth, and that depending the consistency. Consistency, it means if we make the cement paste, whether this is flowable or not, that is nothing but the consistency. So the consistency, there is a percentage, how much consistency of that particular cement that we can calculate by using this VCAT apparatus. So this is the particular VCAT apparatus. So by using this VCAT apparatus, we can find the consistency of cement. So the next physical property of cement is the setting time of the cement. So what is setting time? So the very important physical property is the setting time. See, cement set and harden when water is added. If we add the water into the cement, it will be set and it will harden. So this cement time can be vary depending upon the multiple factors. So there are multiple factors are there. So on the setting time, varies the setting time. So such as fineness of cement, water cement ratio, chemical content and admixtures. So how the vary setting time? So depends upon the factor, and that factors are the fineness of cement, water cement ratio, chemical content and admixtures. So cement used in construction should have a initial setting time that is not too low, and final setting time are measured. So initial setting time and final setting time, two setting times we are measuring, and the range for the initial setting time is in between 30 to 45 minutes. It should not be less than 30 minutes, and it should not be greater than 45 minutes. So in between 30 to 45 minutes, initial setting time will be measured. So when the paste begin with the stiffen noticeable. So again, for this initial setting time, we are using the initial and final setting time, we are using the VCAT apparatus. and the initial setting time will be within the 30 to 35 minutes, not less than 30 minutes. Then final setting. So final setting, it means when the cement harden being able to sustain some load, and it should not be less than, sorry, it should not be greater than 10 hours. 10 तासापेक्षा जास्त. So should not greater than 10 hours final setting time. Final setting time should not be greater than 10 hours. It means 600 minutes, not more than 600 minutes. Okay, so this is related to initial and final setting time. Now we will see how to perform this initial and final setting time. So this is the VCAT apparatus. Again, we can use for the measure the initial setting time and final setting time, that we will see how to measure. So here, so for find the setting time, this apparatus we have to use. So apparatus are VCAT apparatus. Balance means weighing balance is required. Measuring cylinder is required. Stopwatch is required. Glass plate is required. Enamel tray is required, and trowel is required. So these are the apparatus required for making the conducting the setting time test. So initial preparation, what we have to prepare, how to cement paste we have to prepare for setting time to conduct setting time test. See, so consistency test is done before this starting of the test. So before start of this test, we have to perform the consistency test, and the water is required to give paste normal consistency. So for as at a normal consistency, that much water we have to add. So how we can prepare the sample? Take 400 grams cement and prepare neat cement paste with a 0.85% of water by weight of the cement. So how much water we have to add? 0.85% of the weight of the cement. Then gauge time is kept 3 to 5 minutes. It means for making this paste, for making cement paste of that 400 gram cement, within 3 to 5 minutes we have to prepare this. Then start the stopwatch at the instant time when the water is added to the cement and record time. It means when we started the adding water, at that time 0 to within 3 to 5 minutes, whatever time in the time we have made the paste, that time is recorded at the T1. Then fill the VCAT mold. Whatever paste we have prepared, fill into the VCAT mold. So resting on the glass plate, the cement paste is gauged and above. The fill mold completely and smooth off the surface of the paste, making into the level. So after the filling the paste in the mold, so we have to make the level surface, and then from the top of the mold, and the cement block is prepared, that called as a test block. Whatever cement block we are making, that block is nothing but the test block. So this is the initial preparation. After this initial preparation, we have to conduct the test. So place the test block confirmed in the mold and resting on the non-porous plate under the rod bearing needle. So have you seen the VCAT apparatus? So below the needle, we have to place this mold on the glass plate. Then needle gently until it comes with the contact of the surface test, and block and quick release. So allowing it to the penetrate into the test block. So we have to keep this needle at surface level, and then we have to release the needle, so that the needle will be the penetrate into the block. And the beginning, the needle completely presses into the block. The repeat procedure, quickly releasing the needle after the 2 minutes till the needle fails for about 5 mm measured from the bottom. जोपर्यंत 5 mm डिस्टन्स बॉटम पासून मेजर होत नाही तोपर्यंत आपल्याला निडल इन्सर्ट करायचं. And that time we have to record it is the T2. Then what we have to do? Then determine the final setting time. So this is 5 mm needle is the if the needle reach 5 mm from the bottom, that is the initial setting time, and needle reach, now we have to go for the final setting time. So replace the needle of the wicket apparatus. So for initial setting time, the separate needle is there, and for final setting time, separate needle is there. So now we have to attach, to measure the final setting time, we have to attach the needle to the wicket apparatus. Then the cement is considered finally set when, upon applying the final setting needle gently to surface of the text block, the needle makes an impression. In the final setting time, the needle not having sharp edge, the needle having some impression. So if we place the needle on the cement paste, so the impressions are there. Until and unless the impressions are not observing, that time we have to record, and that should not be greater than 600 minute. Should not be greater than 600 minute. It means not greater than 10 hours. So that time we have to record, that is T3. So that is T3. Now, how we can calculate the setting time? So initial setting time we can calculate T2 minus T1. So whatever T1 part, T1 it means 3 to 5 minutes for making the cement paste. Whatever time required, that is T1, and T2 is nothing but the penetration of needle from the bottom, 5 mm from the bottom, that will be measured as a T2 time. So T2 minus T1, we will get the initial setting time. So here written where T1 is a time at which the water is first added to the cement, and T2 is the time when the needles fails to penetrate 5 mm to 7 mm from bottom of the mold. So these are the T2 and T1 and T2. Then T3 is what? T3 is a time when the needle makes an impression, but the attachment fails to do. So the impression, when the impressions of these needles not seen on the surface of cement paste, then we can measure the T3, and the T3 is the time not more than 600 minutes or not more than 10 hours. That is the final setting time. So in this way, we can measure the initial and final setting time of the cements. So today we will stop here, and we will continue with the next properties of cement, that is the soundness. We will continue in the next lecture. So I will take attendance, and today we will stop here.